All right, so we're going to open with finding the average value of a function. So average value is actually asking you to do. So average value is a relationship involving the integral, as we know. So it's going to be the integral from 1 to 7 of x squared times the square root of x minus 2x cubed dx. And then since it's average value, it's 1 over 7 minus 1 we times by that fraction. So we end up with 1 over 6 times the integral from 1 to 7. We're going to rewrite this as x squared times x to the 1/2 minus 2x cubed dx, which then becomes 1/6 parentheses 1 integral from 1 to 7 of x to the 3/2, 3/2 minus 2x cubed dx still. Coming over here we have 1/6 parentheses x to the 5/2 times 2/5 minus 1/2 x to the 4th close those parentheses, and we're going to be plugging in from 1 to 7. So using a calculator, this is approximately equal to negative 156.834. And so it's pretty straightforward. It was not a very hard integral to do. Use a calculator at the end. You can take your answers and see if they're reasonable. I just was, we're trying to hurry. So, so we're going to be talking about inverse functions, what the definition is, the inverse function notation, graphs of inverse functions, the horizontal line test, and finding the inverse. So these are all review topics. Let's see if we can remember. We say g is an inverse, the inverse of x, if and only if you compose f with g of x and get out x, and g with f of x and get out x. It's pretty simple and straightforward. So for example, if f of x is x squared and g of x is the square root of x, then when we plug them in, we get those results. The problem, of course, with these two inverses is that g of x has a restricted domain. It only goes from 0 to infinity, whereas f of x gets everybody, the original. So they're not actually true inverses. We'll talk about that a little bit more later. Maybe you remember from last year. We'll see how that goes. A better example would have been x to the x cubed and the cube root of x. But it's use the inverse when x is greater than 0 because that's when the function g of x is defined. So it's common to use the notation f inverse to refer to the inverse function. So f of f inverse of x is equal to x, and f inverse of f of x is equal to x. Graph of inverses have a unique relationship. Here's a graph of two inverse functions. They are reflections across the line y equals x. This is all stuff we talked about last year. This should be a pretty straightforward review. So we know that x and y switch places. That's why they were reflections around the line y equals x. All functions have inverses, but not all functions have inverse functions. So here is the graph of x squared. Here is the graph of its inverse, which is not a function because, of course, it fails the vertical line test. And then we can see that something called the horizontal line test, which we talked about briefly last year, that if there are 2 points, it's not going to pass the vertical line test once we flip it over. So even functions usually do not have inverses. Inverse functions, of course, everything has an inverse relation. The question of whether it's an inverse function. So if we wanted to find the inverse, we switch x with y. So we switch x with y, so we have x equals y cubed minus 1. So x plus 1 equals y cubed, and y equals the cube root of x plus 1. And so f inverse of x equals the cube root of x plus 1. So it's pretty straightforward. If you remember from doing this from last year, it should not be a major challenge. So let's just double check that I know what I'm talking about. Replace the variables, solve, and there we have it. Pretty straightforward. So this is the part that's a little tricky of what we're kind of asking ourselves to do. And then we'll get into some calculus, because there's not really much calculus in the first part of this lesson, 5.3. Most of it's in the second half. So if I wanted to, let's say f of x equals x cubed minus 4x, and we want to find the value of f of x when x is 3, f inverse of x when x is 3. What we're really saying, since we're switching x and y, in this part, x is going right there, right? So 3 goes in, but it's the inverse. So what we're really saying is, hey, f of x equals 3. And so what we're really asking people to do is, anyway, we're really asking people to do is solve this equation, because we want to know the inverse, which means when y is 3. So in this statement right here, it's really saying y is 3. It's a little weird. In order to solve this, we need to set it equal to 0. And it's x cubed. That's the greatest factoring. Let's see what 3 does. The factor. See what happens. So we're just going to do some trials. So will 1 make it 3? Nope, it makes -3. When we plug in 2, does that make it 3? No. Just kind of doing some practices. -1 does. So that's just guessing. Guessing is not my favorite way to handle something like this. But since I didn't know how to solve the equation I created, this is kind of where we're at. And so you can just flip them over, which is kind of fun. And that's pretty much it. We're going to skip this one. Let's go ahead and see if we can figure out the answer to this equation. This one. So this is your challenge, to find the integral of this function. It's a tough one, so let's think about it. Go ahead and pause your screens and see what you can come up with. So I tried to integrate this by multiplying by the conjugate. Still not finding any solutions or thoughts of how to move forward. So I think this is something we're going to be picking up later, about the rules and the shortcuts with these kinds of functions. I just don't know what they are right now. So we'll leave it. My brain's a little muddled. It's probably because of the medications I'm on. So hopefully I'll come up with something, and if I do, I'll tell you tomorrow. Good luck, and we will talk to you soon.